winter 2015. All right, so question 5, QP11, question paper 11. It says that a curve has an equation, y is equal to 8 over x plus 2x. I. Find the y dx and the 2y over dx2. II. Find the coordinates of the stationary points and state with a reason the nature of each stationary point. This was the equation of the curve that was given. Y is equal to 8 over x plus 2x. Okay, and we are being asked to find the expressions of dy dx, and also to find the 2y over the x2. So that's just what we mean, the first derivatives and the second derivative. Okay, all right. So let's see how we can just deal with that. Okay, so we know that for y is equal to 8x plus 2x, the dy dx will be giving us what? Now note that the 8 over x could be written as 8x to the power negative 1, because the x could be lifted up. And by the rules of indices, if a variable goes up, it carries a negative exponent. So this is 8 to the power negative x plus 2x. Okay, so when you differentiate that, that's going to give you 8, then the negative 1 comes here, then the x we subtract, that gives you minus 2. Hope you are fine. All right, so the next part is the 2x. When we differentiate 2x, we get 2. Okay, so our dy dx is going to give you minus 8 all over x squared plus 2. Watch that. Hope you're okay with this. All right, so this is the first derivative of the function y over 8x plus 2x. Now, for the 2y over the dx2, we are looking at the second derivative. How do we deal with the second derivative? It just follows from the first derivative. We try to differentiate it again. So let's just watch this one here. When you differentiate this, the minus 2 will now come here, and it is going to convert this to positive 8. Like this negative will affect that. That gives you positive, okay? So we're going to get 16. So that is 16. Okay, then for the x, we subtract 1. That gives you minus 3. All right, so our d2y over dx2, okay, is going to give you 16 over x cubed. Hope you are fine. Now, obviously, when you differentiate the constant, it gives you 0. So the 2 would move to 0. Are we clear with that? All right, perfect. So that is the value of the dy dx, and dy dx equals minus 8 over x squared plus 2, and that's also for the dy. That's the I part. Okay, now the IR part mentions that we should find the coordinates of the stationary point and state with a reason the nature of each of the stationary points. Okay, we should find the stationary point and state with a reason. So how do we deal with that? We should find the stationary point and state the nature. Okay, so for stationary points, we know that your dy dx has to be equal to 0. Let's quickly do that. So at st point, okay, so we take our dy dx and equal to 0. That's going to give us minus 8 over x squared plus 2 equal to 0. Hope you are fine. Now, when we resolve that, we are going to get minus 8 over x squared equal to minus 2. And hence, our x, after you have slotted that, is going to be the root of positive 4, which is plus or minus 2. So our x is equal to positive 2, L, x is negative 2. These are the stationary points that we are looking at. Now, this is the second derivative function test. What tells us the nature? So if you want to just know the nature of the stationary points, the only thing we need to do, guys, is to what? Take the positive 2, slot it in there, and see what we get. Okay? Afterwards, you take the minus 2, you put it in there, and see what you get. Then out of the results, we'll be able to conclude the nature of the stationary points. All right, so let's take the positive 2 and put it here. So at x equals to 2, okay, our 2y over the x2 will be 16 over 2 cubed. Now watch, obviously, when you have 16 over 2 cubed, the answer is clear that you're going to have a positive answer. Okay, it's going to give you 16 over 8. You're going to have a positive answer. So once your d2y over dx2 is going to be positive, then we say that it is greater than 0, and hence that is a minimum point. So this point is what? Minimum. The reason being that the whole of that is greater than 0. Okay? The test. Once greater than 0 is a minimum point. Now let's test for the -2. All right, so at x equals to -2, we are going to have our d2y over the dx2 being equal to 16 over -2 cubed. Now watch that. A second. Have you seen it? At x equal to -2, your d2y over the x2 is going to give you 16 over -2 cubed. Now when you work that out, you're going to have a negative answer. And what does a negative mean? For a negative, it is less than 0, and therefore that is a maximum point. So we say at this point, it is what? Maximum. Okay, so our curve is minimum at x equal to 2, and it is maximum at x equal to -1. And that is the answer to the question 5 of question paper 1-1. Question 5 of question paper 1-1. You're able to get your dy dx component. You find the d2y over dx2. Then you're also able to test the stationary points to see their nature. Question 5, question paper 1-1. 2015 winter question 9 QP13. A curve passes through the point A, 4, 6, and is such that the y dx is equal to 1 plus 2x to the power -1/2. A point P is moving along the curve in such a way that the x-coordinate of P is increasing at a constant rate of 3 units per minute. I. Find the rate at which the y-coordinate of P is increasing when P is at A. Okay, so for the question 9 of QP13, we are being told that the curve passes through the points A41 and A41 and is such that dy dx. Let's look at the dy dx function that was written. So we have dy dx being equal to 1 plus 2x raised to the power -12. Okay? And we are saying that a point P is moving along the curve in such a way that the x-coordinate of P is increasing at a constant rate of 3 units per minute. Okay, so that the x-coordinate of P is equal to 3 units per minute. So we can say that the x dt is equal to 3 units per minute. So the x dt is equal to 3. All right, so we have the point A that has been given also to be 4, 6, right? And we are saying that find the rate at which the y-coordinate of P is increasing when P is at A. So we want to find the rate at which the y dt is increasing when P is at A. So what do we do here? What do we do in this particular problem? All right, so obviously we are looking for dy dt. So we can say that our dy dt is going to be something that starts with y and also ends in t. Okay, and like we've always said, the only variable that connects them is going to be the x. So you have dy dx over dx dt. Fortunately, the problem has given us the value of the x dt to be 3 units per minute, and that's what we have here. So we just try and evaluate dy dx. Now let's look at dy dx, and we will see the value of dy dx at the point A, because that's what eventually we are interested in finding for the dy dt. Now for the dy dx, we've already been given the value of the dy dx here. Okay, so the only thing we have to do is to just try and input the values. So for dy dx, and remember this happened at point A, and at A our x is 4. Okay, so what do? We just slot the 4 in there. Okay, so we're going to have 1 plus 2 raised to the power, like 2 to bracket 4 minus half. And what do you get for that? What do you get for that? So 4 to the power half is the same as 2 over the square root of 4, which is 2. Okay, so you're going to have 1 plus, okay, 1 plus 1. Okay, because 4 to the power negative half is the same as 1 over 4. 1 over the root of 4, and the root of 4 is 2, so 2 over 2 is 1. Our dy dx is going to give us 2. Okay, so since our dy dx is 2, how do we find out dy dt? Dy dt is going to be the product of dy dx and the x dt. So we just put them together. This is going to give us 2 times what? 3. And that's going to give us 6 units per what? Per minute. All right, so the expected value for the dy dt is 6 units per minute. That is how much the y is increasing. Question 10, QP 13, 2015, winter. The function f is defined by f of x equals to 2x plus bracket x plus 1 raised upon negative 2 for x greater than minus 1. I. Find the first derivative f prime of x and the second derivative f double prime x, and hence verify that the function of f has a minimum value at x equal to 0. So for the question 10, of QP 13, we have that function that was given us here, f of x equals 2x plus x plus 1 raised upon negative 2. And the question is asking us to find the first and the second derivative. So f prime x, f prime prime x. All right, so we want to find the f complement of x and also the f prime prime of x. So what do we do? As we know, this signifies the first derivative and the other one also signifies the second derivative. And we've been told that we should verify that the function has a minimum value at x is equal to 0. So first, let's try and find the first derivative, okay? Okay, so your f prime of x, as you know, try to differentiate this. This one's going to give you 2 straight away. Hope you know that. Then with this, the minus 2 will come here. So plus minus 2, then x plus 1, negative 3, because we subtract 1 from the numerator, times, you differentiate what is in the bracket, which is still 1. Okay, so your f prime of x, which is our first derivative, is going to give us 2 minus 2 over x plus 1 cubed. We are fine. Okay, so now let's look at the second derivative too. We've been told that we want to find the f double prime of x, that's the second derivative, okay, which actually is the test of the stationary point as to whether it is maximum or minimum, as you well know. Okay, so we differentiate this one more time. And when you differentiate that, the 2 will go to 0. Okay, so the minus 3 will come here, and that's going to give you positive 6. Or positive 6, then you're going to have times x, okay, x plus 1 minus 3 minus 1, which gives you minus 4. So the second derivative of the function f is going to give you 6 all over x plus 1 raised to the power 4. So let's look at that. Are we okay? So now the question says that we should show that it has a minimum value at x equal to 0. So this is the test of the minimum value of a function. Once you do the second derivative test, it should be able to tell you with a proper value of x whether the function is minimum or maximum. So what do we do with the x equal to 0? You just slot it in here. Hope it makes sense. Okay, so at x equal to 0, we have your f double prime of x being equal to, we put 0 wherever we find x, and that's going to give you 6 over 0 plus 1, and that's going to give you 1 raised to the power 4 is still 1. And 6 over 1 is greater than 0. So once for the value of x equal to 0, your f double prime of x gives you a positive number. That point is maximum for the value of x. Hence, we can say that at x equal to 0, it is true that the function is minimum. That is the question 10, question paper 13 for you. So you have your solutions there.